Hi, welcome to howtostats.com. In this video I'm going to be performing a linear regression. Now linear regression is a model-based technique that is an extension of Pearson correlation. So I'm going to assume that you already know how to do a Pearson correlation in SPSS, as this is a little more complicated and involves a few more terms in its output. So what I've got here are fictitious data, but from memory I actually simulated these data years ago to actually correspond to a real study that was done probably in about 1990, in the late 1990s. And what we have here are years of education. So these two people have completed up to the 8th grade, and if we go down to the last number of people, we have up to 18 and 21 years of education for this sample of 25. So this is, you wouldn't typically do a study with just 25 people when you do a regression analysis, but this was simply for demonstration purposes. So we've got years of education, and I'm going to use years of education to help predict earnings. Now these are weekly earnings for each participant, 1 to 25. So the first individual had 8 years of education, and they also earned $77 a week. And as I mentioned, I'm pretty sure these were real data, and I actually wanted to determine in this regression analysis not only whether there was a positive association between education and earnings, which a Pearson correlation can tell you, but I also wanted to know, if you increase your education by 1 year, how much extra money can you expect to earn on a weekly basis? Of course, you can extrapolate these data into annual salary if you want, but these were based on weekly data because I suspect that's how the results were in the study, and I wanted to replicate it in the study. So that's the question here. Is there a correlation between education and earnings? Presumably positive. As education goes higher, earnings go higher. But also, if I increase 1 unit of education, if I go from, say, 11 years to 12 years, how much extra earnings can I expect to get? And we can address that question with linear regression. Now, to perform the analysis, go into Analyze, Regression, Linear. Now, the dependent variable here is earnings. I want to try to predict earnings with education. So the variable being predicted is the dependent variable, and the variable that's the predictor is education. So that goes into independence. Now, what statistics do I want to be outputted from SPSS in addition to the automated, already checked output values? I also want confidence intervals. I like to look at the confidence intervals, and I like to look at descriptives. You wouldn't use R-squared change in this. That would be more for a multiple regression analysis, and part and partial correlations as well. Collinearity diagnostics are also multiple regression. So confidence intervals, model fit, descriptives, and estimates. Continue. What kind of plots will I want to look at? Now, this is important when you want to test the assumption, or the main assumption associated with linear regression that does occasionally get violated, and that's the assumption of heteroscedasticity. Now, I know that's a mouthful, heteroscedasticity, but it basically means, in general terms, it means differences and variances, but it's a term that's mostly in ANOVA and t-test. People talk about homogeneity of variance. They don't use the word heteroscedasticity, even though technically they probably could and it would still be accurate. For whatever reason, in various disciplines, people reserve the term heteroscedasticity to the linear regression context, and that refers to the observation that the variance of the residuals in your analysis are not consistent or constant across your predictor variable. I guess in a nutshell, you could say that's what heteroscedasticity is. So basically, the predictive power of your regression analysis should be roughly equal from low levels of the x value to high levels of the x value. And we can examine that assumption through a few options in SPSS, and I'm only going to check a couple. You can really get sophisticated in how you test this. I'm going to be very basic. You can look at the histogram of the residuals. So these are the residuals